Tyler Young. I have been kind of kicking around the Elixir community since 2019, and I've given a handful of talks. They kind of fluctuate wildly between having like no code at all, because they're like talking about high level things, and then being all code. And you happen to find yourselves in an all code talk. So if you'd like to follow along on your own device, you can grab the slides. TylerAYoung.com is my blog, and then I'm on Twitter and Mastodon as Tyler A. Young. So with that, let's get started. Today, we're going to build the most exciting portion of a CMS, a blog engine. We're going to build the permission system. And if you've built one of these in real life, save your groans for later. We're going to have 4 roles in the system. We've got a logged out viewer, an anonymous viewer. This is, somebody who just visits the website. You hit newyorktimes.com, you're an anonymous visitor. We've got a logged in viewer, somebody who has permissions to actually log into the system, see draft posts and that sort of thing. We've got authors who can create their own posts and edit their own posts, and then we've got editors who can, in addition, edit other people's stuff. So let's look at some code. I'll save you the agony of watching me TDD this. We have a bunch of tests here. We've got anonymous visitors can view a published post. Anonymous visitors cannot view a draft post. Anonymous viewers can't create a post, and so on. Logged in viewers can't create a post. In total, if we grep for test, we have 20 tests. And that sort of makes sense because we had 4 roles times 5 permissions. We've got 20 different tests. And if you're like me, if I'm coming into the system and I'm trying to get a handle on what the permission system does, this is a really poor way for me to grasp it. The logic of what this is supposed to be doing is kind of spread across 100 lines, 130 lines. Whereas I can look at this table and grok immediately what it's supposed to be doing. The table is a really dense, nice way to communicate. So so much for tests as documentation. And of course, if you've actually built one of these, you don't just have 5 rows and 4 roles. You've got 8 rows and 50 rows. The test suite grows significantly. And this is kind of the dark side of testing. It's something we don't talk about very much, but code is a liability, and your tests are code. And all else being equal, we should prefer having a test suite with fewer tests. All else being equal is doing a lot of heavy lifting in that sentence, because of course what I mean is if you can have the same level of confidence in your system while having fewer tests, that's a good thing. Your test suite will be faster to run, faster to write, of course. There will be less to deal with when you're trying to change behavior later, because inevitably, this permission system is going to change. Product's going to come in and say, actually, this role should not have this permission or whatever. And of course, having fewer tests means there's less to read when you're trying to understand the system, when a new person on your team is trying to come in and make sense of it. So the question is, can we get the same or even better confidence by writing fewer tests? And I've got a few ideas for how we can do that. The first is just to put more assertions per test. There are certain schools of TDD that are very insistent that you should have 1 assertion per test. I got to say, I do this, I advocate this, I've never had any problems. In the event that this test fails, it's okay to go fix that before you see the other failures. Doesn't happen very often. Now, of course, if we run this, pardon, I've got an alias, a shell alias that is just total muscle memory. It's MT for mixed test. Anyway, I'm going to be doing that. I can't stop. So if we run this, we get a failure. And it's in this test, and it's on line 19. And it says, assert, let's see, anonymous visitors can view a draft post. If you go back to the table, okay, anonymous viewers were not supposed to be able to view a draft post. So oops. How did this happen? I swear to you, this was a real error I made while composing these slides, and the answer is copy and paste, right? If you're like me, you see a block like this, and your eyes tend to glaze over for the whole left half of this, right? So this was supposed to be refute that anonymous visitors can view a draft post, and we run there. Okay, all right, that works. So the question becomes, can we clean up some of this boilerplate that gets kind of copied and pasted around? One idea for doing that is to have a for comprehension. And we kind of separate out, like, here's the expected value, and here's the thing we're checking. So it should be true that anonymous visitors can view a published post. It should be false that they can view a draft or edit a post and so on. And this is nice. There's nothing wrong with that. If we run it, it works. Cool. And the question is, can we go further? We've got 4 tests here, one for each role. What if we just smash the whole thing together? So we've got 1 test now. User permissions match their role. We do some setup, and then we've got this table. This table's kind of nice. It has a certain appeal to it, right? We've got the view permissions group together. Okay, everybody should be able to view a published post. Let's see, editing other people's posts, editing your own posts. Like I say, it has its appeal, but if I run this, we get a failure. And okay, so the failure's on line 48. Okay, we expected true to be false. All right. Now, I'm a computer scientist. I know how binary search works. I could go and eliminate half these lines, and we could get there. But that's maybe not the best developer experience. So what else can we do? In Elixir 1.18, which is to say the upcoming release of Elixir, there is this new feature to XUnit case, which is the parameterize flag. This takes a list of things that are going to be merged into your test context. So here we say, for each permission level, for each state of a post, whether it's published or draft, and for each value of whether you're the post creator or not, we're going to rerun this entire test module. And what's kind of cool is that it'll actually it'll run those test cases in parallel, which is nice. So all of that expands to something that looks like this. We'll run this whole module once with anonymous permissions on a published post where you are the post creator. That doesn't really make sense, but bear with me. And so all of that gets passed into the test setup. So we can pull out the permissions and the post published state and all that, create a post, and then pass it along into our test here. And the test just says user permissions match their role. And we say, okay, we should expect that you can view when the post is published, or you're the editor, or you're the author and the post creator. And then we make that assertion. Now, I can't run this. I tried briefly to set up Elixir 1.18, but I wasn't willing to destroy my work laptop or risk destroying it. But trust me, it'll work, probably. But I like this a lot. It is somewhat limiting that the whole test module gets parameterized. So if you're like me, this is going to effectively mean you can have 1 test per module, unless you have parameters that aren't actually used at all in the test, which is fine. I think Jose's example when he introduced this was testing registry, where I think the parameters were more or less unused. Yeah, so what if you have parameters that do affect the test behavior that you do want to conditionalize on, and not necessarily at the module level? This is the part of the talk where I utterly shamelessly plug my own library. I've got this library called parameterize test. It exports a single macro that you probably care about called param test. And it's going to do something broadly similar. So we say param test, and we've got the name of the test, permissions match user role. And then we've got this vaguely markdown looking table. And each of these columns is going to be turned into a parameter that gets passed to our test context. So we've got permissions, the published state, the post creator, and this is actually going to be like the thing we're asserting against. So we're saying you should be able to view when you're an anonymous viewer and the post is published and so on. You should not be able to edit. So the test setup here is actually totally identical to this one, which is kind of nice. Like it works on the same principle, right? This stuff goes to your test context, and it can create some new stuff based on that. So the actual test is extremely simple. We say permissions.canView should match what we expected in that table. And if we run this, we get a failure. And it says, okay, so there's the test name that we saw at the top, and it's going to kind of dump the permissions, or not the permissions, the parameters that were in the table. And so we could go and look up in the table and say, okay, so it says author, published is true, post creator is false. Okay, let's see. We said you should be able to edit when you're not the creator. I think that's the one. If we rerun, okay, well, I didn't find it. Trust me, we could go through it. But that's kind of annoying. So instead, the param test macro also takes a special description column. If you provide a description, you can kind of explain, like, why did you choose this combination of values? What does this row mean? So anonymous visitors can view published post. Anonymous visitors can't view drafts. And if we do this and run that, we get a failure, and that description goes into the test title. So, oh gosh, authors can view others' published post is the line. And so if we go there and look, it says that it's true that you can edit another user's post. Well, that should be false. That's the whole point of the distinction between author and editor. So if we fix that, it passes. I like this a lot. When your table is very small, you can probably get by without a description. In practice, I've been putting them in every time because it really aids the debugging process when that needs to happen. So, what are these permissions? I think of permissions as an example of what I call a policy. And a policy is like something that you get handed in a requirements document that is not, it's not some immortal truth of the universe. Like, it's not like every blog system that has permissions is going to look like this. And in fact, our own team's permissions might change 6 months from now when we totally flip-flop on something that was absolutely unnegotiable. There's no like global truth here. It's just, this is what we decided. Humans are squishy, and these are some squishy rules that we set down because we thought people would like them. This is kind of the opposite of invariance. It's the opposite of math, right? If your product manager comes to you tomorrow and says, hey, you've got this add function, but on Tuesdays for super admins, 2 + 2 should be 5. Hopefully you will say to them, like, what are you actually trying to accomplish here? Like, math is an invariant, right? And it's not something that, your add function shouldn't take a user struct pattern match on, right? Solve that at a higher level. So this brings us to property-based testing. Property-based testing is this idea that you can generate some random inputs based on parameters that you provide, and then you can use invariants, or properties, of your system to make assertions about them. So you can say, the example that they always use, that you've probably seen so many times you're sick of it, is a function that sorts a list. There are 2 properties of a list sorting function. They are, it should have every element and no additional elements from the input. The output should have those. And every element of the output should be greater or equal to the thing before it. If you implement a function that provides those invariants, it is a list sorting function, and it is a correct one, period. That doesn't necessarily apply to the permission system. Similarly, yeah, encoding and decoding should produce the thing you started with. That's another like property, but not all code is heavy on invariants. We can find some in the permission system, right? You can kind of squint at the table and come up with a few invariants that it currently maintains. Might not maintain forever, that's okay. Such as permissions increase from left to right. So a logged in viewer should have more permissions than a logged out visitor. Authors should have more permissions than viewers, and so on. You should never have more permissions on drafts than you have on published posts. And owned posts should never have less permissions than ones you don't own. Okay, so that kind of provides a check to, like our parameterized test. But you can't really derive this whole table from that set of invariants. It's an addition, but not a replacement for the example tests. So other examples of policies. Logged in viewers can see draft posts, right? We could change that policy later. There's a button on the home page labeled sign up, right? That's what our designer handed us, but why isn't it called create an account? Because they said so. The free plan gets features X and Y, but the professional plan gets feature Z too. Again, Next week that could change, but today, that's what it says on the website, so that's what the system better implement. We better have a test that makes sure people get what they paid for. And similarly, trials are 14 days. Why not 7? Why not 21? Because the website says 14. So let's look at a function that does have invariance that we can write a property test for. So this is a function for producing a relative date time. So you get a timestamp, and you want to put something on your blog post that says, like, vaguely, when was it published? We don't want it to say 14 days, 5 hours, 13 seconds ago. It's a little too fine-grained, right? Let's say 14 days ago. One change we'll make to this before we actually get into it is pass the now in. If you've done this a few times, you know that when these tests go and run in your CI system and it is dog slow, you occasionally get in this situation where the test starts and then you get descheduled, and then 5 seconds later it comes back and finishes the test and it breaks. Very annoying. So pass in the now. So let's look at what this test looks like. So we could, of course, do a traditional test. We could say relative date time produces just now for times less than 30 seconds ago, and it produces 1 minute ago when your time is less than 90 seconds ago, and so on. That's going to get tedious real fast. What does a parameterized version of this look like? We can have a column for seconds, minutes, hours, days, months, years, and then like what we expect it to produce. So at 29 seconds, it should say just now. At 30, it should round up to a minute ago, and so on. And we would pull all of that stuff out of the context and turn it into, if you haven't seen the new Elixir 117 duration type, it's lovely. You can apply this duration to a date and turn it into like seconds. So very convenient. I like this a lot. And then our test is pretty simple, right? We take the total seconds ago, subtract it from now, and then assert that the relative date time of then is what we expected. Again, this works. In constructing this, it feels a little arbitrary, like we've kind of picked some values and like, what about the edges? And that's kind of exactly what property testing does. So let's look at a property test. So we've got this property that relative date time gives good approximations. We're going to check all instances of this generator. And the generator, I'm using the stream data library here, produces a tuple, and it's got a number of seconds between 0 and 59, minutes, hours, days, months, years. And similarly, we're going to turn that into a duration, turn it into a timeout, and then kind of calculate what we expect. This is a really heavy test, but this is a technique in property-based testing where you have two implementations of the same function. If we look at the actual implementation of relative date time, it looks vaguely similar, but it's different, right? We've got this rounding and that sort of thing. So we're basically like checking our two implementations against each other, and when there's a disagreement, we're going to get a test failure. Now, if we run this, oh, we got a failure. Unlucky. Oh, come on. All right, the test cooperated. So what you'll notice is it's flaky, and the reason for that, in my testing, I think it was flaky probably a quarter of the time, but take my word for it. The reason for that is that we've got 1, 2, 3, 4, 5, 6 parameters here, and the way that the stream data library works is that each time you run the tests, it will run, by default, it will run a property at most 100 times. And in each of those, every time you run it, it'll hit like a bunch of like base cases. So it'll hit the minimum of a range and a maximum of a range. If you've got a list, it'll have a smallest length, the smallest allowable length and the maximum length and that sort of thing. And so we're actually, with 6 parameters, we're actually eating through a good number of the 100 cases and not getting a whole lot of randomness. You can configure that in the runtime config. My recommendation is that you have you override the max runs and max run time. It'll basically run until it hits one of those two, right? You can overrun them in CI, and so what I do is I set the max runs to like something crazy, 100,000, and then set a max run time of like 5 seconds. So in practice, it just runs for 5 seconds, generating random cases each time. If we do that here, it will fail every time. So we got through 203 successful runs before we hit a failure. So what's that look like? Seconds, minutes, hours, days. Okay, so it says at 7 months and 15 days, our implementation function rounded that to 7 months, but we expected 8 months. And so it was in the course of doing this in a real code base that I realized I just don't care. Both the beautiful thing and the terrible thing about property-based tests is that you'll find every single edge of the behavior of your system. And for something like relative date time, this actually wasn't a good fit from the start because the behavior at the edges just doesn't matter. If a user submits an issue that says, hey, I published this 7 months, 15 days ago, but it rounded that to 8 months and not 7, what's up? Obviously we're going to file that in dev null. It's something to think about as somebody who has been, like, for years I have worked more property tests into my repertoire. You got to decide whether it's worth the effort to get that property test to be reliable. We talked about improving test coverage in CI. Yeah, set those limits higher. There's one more type of testing that I want to talk about, and that is snapshot testing. And this is kind of a novel take on the idea of testing. And the idea is, what if we record the behavior of the system now? We're going to call that like the correct or canonical version, and in the future we'll compare it against this one. This is super useful when you come into a code base that is massively under-tested. You don't have time. You don't have the inclination to write a whole bunch of tests to improve test coverage. So you just say, whatever it's doing, call that good. And in the future, when we get changes, we can look at those and say, like, did I intend to do this, or was this an accident? A couple libraries that are available in Elixir, assert value is kind of the generic one, and heya is specifically for live view. There are also like two philosophies on this. One is that the snapshot testing library should modify your source code for you, and the other is that it should just save the result to a separate file that it can check later. Again, like either's fine, kind of just a preference thing. So let's look at a snapshot test. I debated on doing like a really complicated example because, realistically, if I were testing a system, I'd do these snapshot tests on a really big value because that hit a bunch of systems. We're gonna start with a simple one. So if I run this, we're going to get some output. You don't often get interactive output from your test, but it says test slogan is correct. Assert value failed. You said nothing about what it should be, but when we ran your blog.slogan function, we got hello ElixirConf 2024. Do you want to accept this value? We say yes, and it will modify the test, and then we can go commit that to CI. And in the future, if this changes, let's say we change the implementation, if we rerun this, it's going to say, hey, this failed. You said it should be this, but we actually got an exclamation point. Do you want to accept that? If we say no, the test fails, and if we say yes, it goes ahead and makes the change. There's our exclamation point. Again, this is more useful if let's say you're testing a live view and you've got, assert that the whole value of the page doesn't change, right? The initial render should be the same. And then in the future, when you get a diff, you can say, did I mean to do that? So fundamentally, I don't think any of these techniques is like the one way to test. There's not one right way to do things, but they all have drawbacks. They all have situations where they're more appropriate and less appropriate. And fundamentally, I feel like you just don't understand a tool until you know when not to use it. If you've got a hammer and you think you should always be using a hammer, maybe consider other tools. Try them out, figure out when one's appropriate. So let's kind of compare what we've talked about. So traditional tests have the absolute lowest barrier to entry. They're a little slow to write. Just a fact. It's worth it, but they're slow. The maintenance and extension, so as your system changes, as you add new features, as you change the existing behavior, is linear in the number of tests that you've written. As somebody working on a code base with something like 3,000 or 4,000 tests, I'm starting to feel that linear cost of changing the existing system. There's a weight to those tests. Furthermore, the logical grouping in terms of like how well does this group-related functionality is low. You can try to keep stuff in the same block, but when it's spread over 500 lines, there's a grouping problem. And so communication with your teammates as they're coming on board or picking up a new part of the system is mixed. Parameterized tests have a low barrier to entry, but not none, right? You have to either learn the Elixir 118 feature or you have to install a library. They're slower to write just because you've got more test cases to handle, more situations to think about. But the maintenance and extension of them is sublinear. You've got like one place to edit your test rather than many. And thus you also get high logical grouping, and I would argue it communicates much better. When you've got a table like that looks vaguely like Markdown, you can send that to your stakeholders, and they can say, oh, see, you're saying that anonymous viewers should be able to do this. I actually meant that they should not, and that's a nice way to communicate across the team, especially when your test tables can look like a requirements document that you got. Property tests have the highest barrier to entry and are the slowest to write, but again, maintaining those over time takes less effort than having many different tests, and they have a high logical grouping. Communication, I would argue, I've seen really, really communicative property tests, and I've seen ones that were kind of bewildering. It's mixed, right? All of these are mixed, but I think property tests are more mixed than most. Snapshot testing is obviously quite fast to write, but has lower communication value, especially if you're just asserting on the whole value of a web page, right? Like what was it your coworkers might ask that you were really focused on here? And the answer is, I don't know, the whole thing. So when might we use these? If you've got unconditional behavior, like as the implementer of the function, let's say you're going to send an analytics event every time a post is created. Don't write a parameterized test that parameterizes on the type of user and the content of the blog post, right? It's unconditional. Just write a traditional test and be done. Similarly, if it's low impact, if this is something that is nice for your system to do, but not, it's not dealing with, are users going to lose data? Traditional test, snapshot test, and depending on the case, parameterized test, totally fine. I would not invest the time and the resources to do a property test in that case. If you've got policies where you've got like a bunch of parameters that your behavior depends on, parameterized tests are very nice, and property tests can be a good way to double check that. If you have true invariance, you've got something that Edsker Dijkstra would have written about, use property testing. It's great. And there's never been a time that I've written a property test that I haven't found bugs in my implementation, even when it was previously well tested, or I thought it was well tested. And finally, if you've got low existing coverage, snapshot testing is a good way to improve that pretty quickly with a minimal amount of effort. Okay, that's all I've got. I am a contractor. If you're needing development or consulting, give me a shout. That's it.
Do we have questions?
I really liked that testing table that you had, and the like the one in the slides, I guess, with the original with the checkbox as well.
Yes.
Have you considered, like, I feel like you could find a way where that sort of you condense the headers in the in-test like doc string to be more like these states rather than the actual properties that define that state?
Yeah,
because if it looks like that, that's even easier to communicate to product, I think.
That is the gold standard. One thing I encountered as I was making this up is that this table kind of implies things but doesn't say them. For instance, should this behavior apply to posts that you don't own, and that sort of thing. But I agree, I would love to find ways to make the param test look more like this. Like the closer you can get to this, that's like the gold standard, right? Yeah. Certainly open to ideas for that.
Cool. Thank you.
So I was taking notes and I missed how you executed the snapshot test system.
Yes, it's actually just mixed test. Oh, this one's correct. But yeah,
Oh,
every time that there's a difference, it does that.
oh, so I'm sorry. I guess maybe I missed how you set it up then. So how does it know that it's looking for that?
Yes. So
That's
import
the
assert value.
Assert value.
Yeah, assert value is the macro rather than assert. Yeah. And yeah, the first time I wrote this, it was like it just looks wrong. Like, are we just asserting that blog.slogan is going to be truthy? But no, in fact, it's going to give you an error.
Okay, I guess I saw it. I just didn't understand it. Okay, perfect.
Yeah. Again, my eyes glaze over at the left half of the line all the time.
I assume that for assert value, there's some way of running that so that, like, let's say, like I'm doing a big refactor or something. I know ahead of time that I only care about regressions, and I'm not actually going to be interested in, hitting yes over and over and over and over. Is there like some kind of way of telling it, like, just run it non-interactively?
Good question. Yeah, in CI, I believe it does run non-interactively. Surely there's a flag to say. I don't know. I don't know is the answer, but the docs are pretty thorough. Oh, come on. Non-interactively. Okay, yeah. So you can set the assert value accept diffs flag to either ask yes or no. Yeah.
In 118, the parameterized tests, are those output failures readable?
Honestly, I don't know. I tried to run it. I'm not going to be able to find the commit right now. I'm sorry. I know that Jose had an example of what it looks like in the failure, but I did not look carefully at it enough to remember. Apologize.
When you got like a mixed a test environment with like parameterized and traditional, does it play well with like Elixir's concurrent, trying to run everything, all the tests at the same time?
Yeah, so the built-in stuff in 118 does. It runs each module in parallel, assuming you've passed async true, of course. The param test macro does not. It's as though you just copied and pasted the test within your single module. That would be a cool addition.
I think in your property test, or in your presentation, you had a flaky property test, and I see like often what you do is you just rerun it and move on. Is there a way to like combine property test and snapshot where if there is a flaky test, it'll continue running that same like seed, so you can't just retry?
Yes. So if we run, oh boy. All right, here, let's go run this specific test. Where was it? There we go. If we rerun, okay, hang on. So every time that the property test fails, it tells you what the seed was. And so if we rerun this, I think it's -- seed, and paste that, it should fail in exactly the same way. Yeah, so you can see it was, oh, somehow we produced 1 minute ago. Oops. So yeah, if we rerun that again, yeah. So and this is actually true not just of property tests, but every XUnit run prints the seed, which is useful if you have tests that accidentally depend on the state of the others or the order that they're run in. You can rerun it with the seed.
We have time for one last question.
When writing the property tests, how do you ensure you're not just repeating the same implementation in your test that you have in the code?
By being very careful. I mean, yeah. So that's one of the downsides of there are. I'm blanking on the name of the canonical Erlang property test book, but this technique of like we've got something that vaguely looks like the same implementation, but it's meaningfully different, and meaningfully can depend, right? It depends on your situation. That technique is kind of like I think it's like the third one he talks about, but the idea of like, the encode and decode, like round trip, and something that vaguely looks like math is like more common, I think.
Oh, sorry. Go ahead.
One more thing I'll add is that sometimes you have an algorithm that is like really complicated because you had like performance needs and you've got caching or whatever, and you can come up with a simpler, like dumb implementation that you can kind of look at and be like, I know it's correct. Everybody uses Fibonacci for this. You can make a slow implementation of Fibonacci and maybe you got a faster one. That would be an example where you're like comparing the two and can feel pretty confident about those two.
If you have more questions, feel free to reach out to Tyler. Thank you so much.